Here's the integrated 3. It's problem 5-49. It says David and Regina are competitive racers and they both aim to break 2 minutes in their respective races. They're trying to figure out who has the more difficult challenge since they compete in different sports. David runs the 800-meter race and Regina swims the 200-meter freestyle. They agree to accept the following standards for high school boys and girls. So I'm going to write some of this down. I actually have a little sketch here. So for the boys, which is going to be David's race, the mean time is 149. So I wrote that down, 149 seconds, and the standard deviation is 13.6. And for the girls, the mean is 145 with a standard deviation of 8.2. So I just wrote those down because I want to make some histogram, like a normal distribution histogram for each one of these. So, and then it says currently, this is where I got messed up. It says currently David's best time is 2 minutes 2 seconds. And when I converted it to seconds, I went 2.02 times 60, but that's not what it says. It's 2 minutes plus 2 seconds. So to convert this into seconds, you have to go, well, 2 minutes is 60 times 2, that's 120 plus 2. So I wrote 122 seconds for him. Because that's like a little trick, like if you go type that in, something's not going to work. And then Regina's time is 2 minutes 10 seconds. So 2 minutes is 120 plus 10, 120 seconds plus 10 seconds. So that's, I think I messed this one up. Okay, 2 minutes is 120 seconds plus 10 more, that's 130 seconds. Okay, so I'm going to put all these numbers into some histograms, and I'm going to get their percentile ranking. Like, how well did he do in his sport, and how well did she do? Like, was he the 90th percentile and she was the 80th? We don't know. So I'm going to go ahead and share my screen. We're going to do it on Desmos. So here's Desmos. I already actually typed one in. And so I'll show you how to read this one, and then I'm going to type a brand new one because you didn't see how I got this. But this here is called a normal distribution curve, and I put in the numbers for David. Remember, he had 122 seconds. Right here, this is the mean. Remember, it was 149. And the 13.6, that was the standard deviation. And then I clicked this, and I want to know how many people actually swim slower than him, because, you know, like, he beat all the kids that swam slower than him. That's why I have this part shaded over here. So he's in the 97.6th percentile. So I'm writing that on my paper. 97.6th percentile. And then I'm gonna go ahead and show you how I did it. I'm gonna put in the numbers for Regina. So here's how you do it. You go to functions, and then you go to distributions. It might be on this, and you have to scroll over and click distribution. And then it's not a histogram, it's a normal distribution, because we're comparing to the norm. Oh, what happened here? Whoops. Try again. Normal distribution. There we go. And then remember I had the mean, comma, standard deviation. So for Regina, the mean is 145. Comma, standard deviation was 8.2, and that gives me, and I can push this little zoom fit, and it fixes my window, and then I can find some probability, some CDF. I can put some data in here. So she swam, her time was 130 seconds. So I actually want to find how many kids swam slower than her, or how many kids she swam faster than, if that makes any sense. So I'm going to put her number here. And then I see I get 0.96. So that's 96.6%. And then I'm going to, let's go back. Okay, so I wrote that down. So if you saw how I did that, I just went to Desmos, I clicked normal distribution, I put in the mean, comma, standard deviation, then I clicked the normal CDF, put in my number, and I got a percentile. So actually this guy, David, he swam a little faster because he swam faster than 97.6% of the people in his race, but she's fast too, but she swam faster than 96.6%. So he is the winner. Is that all they're asking? Yeah, it just says which athlete's a relatively faster swimmer. We're going to say David is faster. And that's all.